On the first page, you'll notice that there was a fun little exploration that had these things called algebra tiles that some of you did see in my class, but we don't have the opportunity to deal with those, so we'll miss out on a little bit of the fun. But hope that made sense to you. And what you're going to be doing now is if you understand what happened, your assignment is finished until we meet again in our meet session. At our meet session, that's where we're going to do the homework 7.5, and so that's and then we'll do that together in the class. If you guys have the inspiration to try to do some of the work early, I think that can only help you, because I'm not requiring you ultimately to stay for the entire meet session. Everyone does need to come to the beginning of the meet session, because I may have some announcements or things I may have to tell you, but otherwise, if you have most of your work done, once you get 100 on your assignment, I will allow you to leave the meet session. So I look forward to seeing you at our next meet session, where we can tackle this homework and make sure that we understand it really well. Take care, everyone. Have a great day. Hi, class, and welcome to your second video. I just want to remind you, if you have the opportunity, if you can go to my essay, you will find this the blank notes packet in there, which if you have a printer could print out. If you don't do that, please just have a notebook available so that you can practice some of these problems. Please don't expect to be able to figure this out if you don't actually do them yourself. So have that notebook ready. Don't just watch it and think that it's going to work. I think a lot of you have figured out by now that that's not going to happen. So just be ready to practice. Some of this information we've actually done before, and so it is in some way a review. But I want to go over it again, because going to the next section, we're just going to need to be able to be pretty practiced at what we're doing here. So let's get into it right now. So what we're going to be doing is let me just do a quick aside. Is what you learned or should hopefully have gotten out of the first lesson is in this case just the multiplication of two binomials. And one of the ways that we do this is using this acronym called FOIL, and which is basically the same thing as distributing. So the idea again is that we're going to take when multiplying a binomial, we're going to take the first term in the first binomial and we're going to distribute it. And then when we're done with that, we take the second term in the binomial and we distribute that. And basically, doing that is the same thing as this thing called FOIL, where you're multiplying the first terms, the x and the x together, and then the outside terms, the x and the 2 together, and then the inside terms, the 2 and the x together, and then the last terms. And then once we've done that, typically we're going to add up the O and the I of FOIL. So to do this one, let's go ahead and multiply out this binomial. Hopefully this is something you're comfortable with from the last homework assignment. But the first terms are x times x is x squared. The outside terms is the x times the 2, or 2x. The inside terms, the 3 and the x, give us 3x. And then the last terms is the 3 times 2 is the positive 6. And often we're going to find out that in the work that we're doing is the outside and inside, the O and I of FOIL, the 2x and the 3x end up being like terms which we're going to add together to get 5x plus 6. Now, what I need you to recognize is that what we're going to be doing in this next section is undoing that process. So we're going to unfoil it. And to do so, it's worth recognizing a pattern. And this is only a pattern when we have an x squared term that has, in effect, a 1 in front of it. We don't write the 1, but as long as there's if there's nothing in front of the x squared term, we assume it's a 1. And so this trick that we're going to be using for factoring is going to use, it only works for this type of trinomial. So in this case, this is a trinomial with a 1 coefficient in the front. So that's so it meets the criterion. And so what we're going to do is we're going to, what I want you to do is to recognize where this 6 came from and where this 5 came from, this 5x. Well, the 5x came from adding the 2 and the 3 together. And the 6 came from multiplying the 2 times the 3. So let's put that back together again, all right? So this 5x came from a binomial whose second terms add up to 5 but multiply to 6. And the only way that we can do that, probably one of the few ways to do this, is to recognize that the two numbers that multiply is to look at the way we can multiply to get 6. 1 and 6, 2 and 3. Which of these adds up to 5? And it's the 2 and the 3. So I'm hoping that this is a review that you guys can remember. So when we factor, and that's what this is what the process is we're going to be doing. When we factor, we're looking for two numbers that will multiply to the last term, but add up to the middle term. Let's do one more. So here is x squared plus 10x plus 16. Now again, there's a 1 in the front here, so we can use this trick, like I said, to figure out what the factors are that made that number up. So we're looking for two numbers that multiply to 16. Well, how many ways can I multiply to get 16? Well, there's 1 and 16, and there's 2 and 8, and then there's also 4 and 4. But the question is, which of these is going to add up to the 10 that I need in the middle term? Well, the 2 and the 8. So I'm going to take the 2 and the 8. I'll put the 2 here and put the 8 here. You could have put them, doesn't matter what order. All right, and they're both plus. All right, because it needs to add up to plus 10. Okay, so with that little quick review, what I want to do is go into our examples and see if we can't figure out how to factor them. So let me go to example 1. So we're on page 2 if you printed out that sheet at this point. And what we're looking at is this, the problem is to factor this trinomial. One of the notations that they use, just so you can see it, is they typically the format of a polynomial is some number times x squared plus some number times x plus some number c. So typically the last number in a trinomial they often will say that that's the c value. The b value is the number in the middle. So those are little letters that come up every once in a while when we get to more advanced math. It's worth looking at them now. So in this case, the c value is 16, the last value is 16, and the middle value b is 10. So we're looking for two numbers that multiply to 16 and add up to 10. So again, let's go ahead and figure out again. We just did this one actually. What numbers multiply to 16, and that's 1 and 16. Some of you can figure this out in your head. I know that already, but let's go ahead for those of us that need a little bit more work to figure it out. Here are the three different ways to multiply to get 16. Only one of them adds up to the 10. Therefore, we can skip all this work here, and there it is. So the factors are x plus 2 times x plus 8. Why? Again, because we need two numbers that add up to 10 and multiply to 16, and 2 and 8 are them. Some of you often ask, is that the same as x plus 8 times x plus 2? Answer, absolutely yes. All right, let's go to another one. Let's go to our, I guess I'm going to go to the next page. Now on this one, we're looking for, this one's slightly different because the b value for this problem here is -8, and the c value is positive 12. Well, why does that make things different? Well, it makes things different because now I need two numbers that multiply to -8 and add up to positive 12. So think about this though. Two negative numbers. Two negative numbers are going to multiply to give me that positive 12. So if I'm going to factor this, let me write it. I'm going to write it up over here. Minus 8x plus 12. Now at this point, you guys are free to just watch. I'm going to factor it. I know it's going to be two binomials. So I'm going to put an x here and an x here. And think of two numbers that multiply to 12 and add up to -8. Well, the numbers that multiply to 12 are 1 and 12, 2 and 6, 3 and 4. Now, 2 and 6 add up to 8, but I need to add the -8. So what I'll do is I'll put a negative sign in front of both of them, and therefore they're going to add up to the -8. And notice that a -2 times a -6 also gives us the positive 12 that we want. So this is the answer. All right. So at this point, let me see. Let's go to the next page. And this is the last example that you're going to have to worry about. And in this one, you'll notice that the number is -21 and 4. So let me go back up here. My b value is 4. This is the number that it has to add to. And this is the number that it needs to multiply to. So I'm looking for two numbers that both add up to positive 4 but multiply to -21. Well, if it's going to multiply to -21, the trick of this one is to know that one number has to be positive and the other number will have to be negative. And so thinking about all the ways to multiply to get 21, we got 21 and 1, and we have 3 and 7, and that's it. But in this case, we're looking for two numbers that multiply to 21, but add up to positive 4. Well, one thing I could try is I could try -7 and 3, but that doesn't work because positive 3 and -7 add up to -4. I need it to be a positive 4. So some of you already probably recognize that all I need to do is to change the signs of these two. If I make the 7 positive and the 3 negative, they add up to positive 4, but also multiply to -21. So here is our answer. So those are the three different factoring possibilities that you're going to have. But the key to all of them is that you're looking for two numbers that multiply to the last number but add up to the middle number. So what I'm going to ask you guys to do right now, though, is to move to the practice problems. This is where you guys need to have a pencil and a paper, and what we're going to do is we're going to do a problem. I'm going to pause the recording. You're going to do a problem, and then when you unpause, you're going to see the problem done, and then the question is, did you get it right? So I'm going to ask you right now. We have these 6 problems to do, and then we'll be done with the video. But let's see how well you can do on these. And right now, I'm going to ask you to pause, and when you feel like you've got the right answer, unpause and check your work with mine. So go ahead and pause now. Okay, for the first one, number 3, again, we set up the 2 parentheses first, then we can put the W's first, okay, because those are those are the f part of FOIL, right? We need to make sure that we get that w squared, and that's why the w's go in the front. So f of FOIL is first, and it needs to multiply to w squared. And then our question is, what two numbers can multiply to 3 and add up to negative 4? So, well, there's only one way to multiply to get 3. That's positive 1 and positive 3. But we need to add them up. They need to add up to negative 4. So if I put a negative sign in front of both of them, that solves the problem, because negative 1 times negative 3 is 3. And the negative 1 plus negative 3 is negative 4. Okay, let's pause and do the next one. Okay, so the answer, number 4, is n minus 7 times n minus 5. Those are the two numbers that multiply to positive 35 and add up to the negative 12. All right, let's go to number 5. Go ahead and pause and do number 5. Okay, for number 5, the answer is x minus 2 and x minus 12. Again, the negative 2 and the negative 12 multiply to positive 24 and add up to negative 14. Okay, pause for number 6. Okay, this one was a little trickier because what you're looking for is two numbers that multiply to negative 15 but add up to positive 2. So to make the negative 15, we know that the two signs will be different. So in essence, we're looking for two numbers that multiply to 15 but have a difference of 2, that's subtracting one from the others 2. So the only two numbers that work for that would be the 3 and the 5. And we're going to pick, why do we pick the plus 5 instead of minus 5? Well, it's because plus 5 and minus 5 add up to positive 2. So we're moving here. Okay, let's go ahead and pause, and we'll go ahead and do number 7. And you can go ahead and look at these problems as you do number 7 to see if you can get any hints if you're still struggling with this a little bit. Okay, this was a tricky one in a way, because we're looking for two numbers that multiply to negative 30 and add up to positive 13. And if you're not careful, you might fall for this 3, 10 thing. But the problem with 3 and 10 is that their difference is not 13. So the only one that has a difference of 13 is the 2 and the 15. So I make a positive 15 and a negative 2 gives me my positive 13 add up, and then the positive times the negative gives me the negative 30 that I'm looking for. One last one, pause, and then do number 8. Okay, this one was challenging in that there were, I found 4 different ways to multiply to get 42. I'm writing all those. Some of you, I think with time, you're going to find, in practice, you're going to find that you can just do this on your own. You can figure out the numbers. But if they get tricky or you're not sure exactly, I think that writing down the numbers, usually by the time you get to the end, you'll definitely see the numbers that make sense. So instead of struggling, just go ahead and write the numbers, which I can do on more complicated problems myself. So anyway, the final answer is going to be v minus 7 and v plus 6, which again adds up to the negative 1v, and then the positive 6 and the negative 4 give me the negative 42. So that's pretty much it. We're not going to, even though we did, I would have liked the word problem in the other class. I'm going to relieve you of that responsibility of having to understand how this one works. It's the idea is, of course, is to make the length and the width a binomial. So we're trying to find out what. Oh, I'm gonna hold off. I'm gonna hold off on this one. We've done it before, but again, I just don't want to overcomplicate things. Let's keep things simple and make sure that we understand those basic things in algebra. So anyway, that's gonna do it.